Right. Okay. So today we are going to discuss about boot process of operating system. Okay. Guys, do you know Windows boot process? Windows boot process. Do you know about Windows boot process? How the Windows operating system it will boot? Hmm? Yes, no, online. Can you hear me? Right. So let's see here. I'll show you. First of all, we'll discuss about Windows boot process and then we'll do Linux boot process, right? ROM. ROM full form, read-only memory. ROM full form, read-only memory, right? Read-only memory, ROM. So the ROM where it got located? ROM where it will located? No guys, no Manjunath. What happened? ఏమైంది? Okay. So ROM full form, read-only memory, right? So it will be located where? On top of the motherboard. It's a one IC, integrated circuit, one small chip. Okay, the small chip, it will be located on top of your motherboard. So in your CPU, that means in your laptop or otherwise in your desktop, you will have the motherboard, right? So on top of the motherboard will have the ROM called one small chip. Inside this ROM will have the memory. ROM full form, read only memory. That means the memory we can able to read, we are unable to modify, we are unable to edit, right? Clear guys? Read only memory. Inside this ROM will have the one firmware called BIOS. BIOS guys, BIOS. BIOS is a one firmware, right? So the BIOS firmware, it will be available inside the ROM. BIOS where it will be available? The BIOS, it's not going to available in our hard disk guys. So if you doesn't have the hard disk, even if you want, you can find out the BIOS from using few function keys. While you switch on the machine, so the BIOS key it will provide you like F1, F2, F3 like this, depends upon motherboard manufacturer. So we should use those BIOS keys. That means that particular function key we are going to enter into the BIOS. Clear? I hope you got it. EPROM, EEPROM. Okay. Erasable programmable read-only memory. PROM, programmable read-only memory, right? EEPROM, electrical erasable programmable memory. Nowadays we'll have the firmware. We can able to update the firmware. In olden days we'll have the ROM and then PROM, programmable read-only memory. We can able to remove the chip and then we can able to insert the chip. Erasable programmable read-only memory. EEPROM means electrically erasable programmable read-only memory. Electrically erasable programmable read-only memory in the sense, with the help of one electrical device, we can able to erase the ROM. With the help of laser, we can able to erase the ROM, we can able to install the some different ROM. But here, nowadays, we'll have firmware. So usually, for example, if you're using Lenovo laptop, so the BIOS, it will provide you updated BIOS, able to update, but you are unable to modify, you are unable to remove, and you are unable to uninstall the another BIOS into the ROM. Got it? Right, guys? So clear? Next. So coming to here. Yes. So let's see here. the first action, how you are going to start the mission, how you are going to switch on the mission, guys. Power on button will have, a power button will have. So we need to on that button. That is the first action. अगर आप system start करना चाह रहे हो, so we should power on the button, right? So then only the system it will start, right? So that is called post action. Power on self test. Power on post fill form. Power on self test. So power on self test, guys. Post action is a power on self test. Okay. And then BSL, boot stamp loader. So boot stamp loader. So BSL, boot stamp loader. So post full form, power on self test. It will test the, yes, post it will check the all the connected peripherals. So it is going to check self test. System it will check the self test. The next, so BSL, boot stamp loader. How this program it will active in the sense, after start the mission, it is going to enter into the BIOS inside the room. Inside the BIOS, so we need to select the bootable device as a first boot device, right? For the bootable device from the BIOS. So the BIOS, what it will do, so it is going to provide the control to the bootable device like hard disk and those all stuff. So from the BIOS, so the bootloader it will happen and it is going to start the operating system with the help of bootable files. So BSL full form, boot stamp loader, the bootable files it will load and then it is going to start the operating system with the help of the bootable files, right? So next action is a drivers. So driver. So drivers means, so peripherals drivers. So driver is a one piece of software, right? So drivers is a piece of software, okay? So drivers case. So for example, if you're connecting printer, if you're connecting, so like this devices, so we need to install the software related to printer. So we need to install the software related to scanners, okay? So the software is a driver, guys. It will load. So all the drivers related to your components, that means your devices. So if you're having the printer, it will load the printer driver. If you're having the scanner, it will so load the scanner drivers and everything. And finally, you'll get the operating system in GUI mode. I hope you got it, guys. So this is a boot process of our Windows operating system. The first action is a post. Power on, it is going to enter into the BIOS. So BIOS, where it will locate it inside the room. So room full form read-only memory. It's a one IC integrated circuit. So it's a one small chip. So it will be available on top of the motherboard. So in CMOS area. CMOS full form, complementary metal oxide semiconductor. Okay. So clear, guys. I hope you got it right. So now we'll see RHEL 6.0 boot process now. RHEL 6.0 boot process now. Let's see here. RHEL 6.0 boot process. So guys, if you're using any operating system, the first action should post only. That's it, no? We need to power on the mission, then only. Otherwise, It may be Windows operating system, it may be Linux operating system, it may be Mac, whatever it may be. We need to switch on the power button, right? Okay. So you are switch oning the power button, and finally you are going to get the login prompt. That means login screen, student like this, right? In between, we'll have few process. From I'm switch oning the button, guys. So that is called post action. So post action, it got completed. Finally, we'll get the one login screen, right? Student not listed like this login screen will have. In between, we'll have few process that is called boot process of RHEL 6.0 operating system. Got it, guys? So coming to RHEL 6.0, high level, what happened? See, guys. So the following level stages of the typical Linux boot process. That's right, guys. So first action is a post. So power on self-test, power on self-test. Then, so it is going to enter into the BIOS. It is going to search, it is going to looking for the BIOS. From BIOS, it will search the first boot device, right? That's it now. So BIOS will form, so basic input output system. So this BIOS, what it will do in the sense, it will execute the MBR. MBR stands for master. MBR stands for master boot record, executes grep. The first action is a post, and it is going to execute the BIOS. BIOS, it will execute MBR. So MBR will form master boot record. So it will be located inside the first sector of the bootable disk. MBR partition, right, guys? So the size of the MBR is below 512 bytes. 512 bytes, not MBs. It's a very small partition. Okay, so 512 bytes. So this MBR, it will execute grep, guys. Grep will form ground unified bootloader. Okay, so we are discussing about RHEL 6.0 boot process. By default, in RHEL 6.0, we'll have the grep. So grep executes the kernel. That's it, now. Grep contain kernel images, init RD images, init RAM images, right? So grep contain kernel images, init RAM images. The grep, what it will do? The grep, it will execute the kernel. The kernel, what it will do? The kernel, it is going to run the activate the first process ID called initd. You know, na, in RHEL 6.0 in older version, the first process ID is a initd. Coming to RHEL 7.0 onwards, the process ID it got changed as a systemd, the first process ID. So it is going to execute the initd. The init, what it will do in the sense, it is going to execute the run level program. Run level program means in init run levels, we'll have 6 run level. Init 0, 1, single user, more, init 2, init 3, init 4, init 5, init 6, like this we'll have the, so different 6 level modes will have init 0 to init 6. I'll teach you, don't worry. So where we need to, so init, you need to shut down the RHEL 6.0 operating system in the sense you need to use init 0. You need to reboot init 6. You need to keep the like graphical mode in the sense init 5. Okay, so like this we have the etc init tab. There we need to keep the like mode according to our requirement. We'll get, if you keep the init 3 init tab 3, you will get the CLI mode. If you keep 5, you will get the GUI mode. Finally, if you're getting the GUI login prompt, that means you will have the init 5. If you're getting the CLI login prompt, you'll have the init t into the etc init tab file. Clear, guys? So those all the typically 6 stages will have. Okay, right. So now we'll see individually each and everything. BIOS stands for basic input output system. perform some system integrity check. So BIOS, what it will do? It will perform some system integrity check, right? And executes the bootloader program. So what it will do? It will search, it will load, and then it will execute the bootloader program, BIOS, right? So you know very well. So it will looking for the bootloader from one device. That's it, na? It may be floppy, it may be your hard disk, it may be your DVD, it may be your pen drive. That's it, na? Right? It may be floppy, DVD, hard disk. So how you are going to enter into the BIOS, you know very well. So we need to use few function keys to enter into the BIOS to modify the BIOS settings, right? So during the BIOS setup to change the boot sequence. So you know very well how to change the boot sequence, first boot device, second boot device, like this, how we need to keep say inside the BIOS using few function keys, right? So on the bootloader program is detected and load into the memory. The bootloader program, it will be detected. It is going to load in memory means RAM, right? That's it, no? So it is going to load into the memory. BIOS gives the control to it. BIOS give the, it is going to get from the bootable device, it is load into the memory. So it is going to give the control to the system now, right? So simply you can say, so BIOS loads and executes the MBR, master boot record. The master boot record, where it will be available inside our bootable disk. Got it, guys? The master boot record, it will be available inside our bootable disk, inside the first sector of our bootable disk. So you know very well sectors, tracks, cylinders, and those all stuff, right? Already we discussed while we are discussing about the disk management concept at the time, right? Okay. So next, see guys here. So MBR. MBR stands for master boot record. So it is loads in the first sector of the bootable disk. Where from where it is going to load? From the first sector of the bootable disk. It may be pen drive, it may be DVD, it may be your hard disk, right? So hard disk like HDA, IDE hard disk, maybe it's a SATA hard disk, whatever it may be. Excuse me guys. MBR is less than 512 bytes in a size. MBR size is a less than 512. So you can say 512 bytes MBR partition will have internally. So inside the first sector of our bootable disk, right? Okay. So this 512 bytes, it got divided into three components, guys. This has three components, right? So primary boot mission. Okay. So in first 446 bytes, total 512 bytes, right? In this total 512 bytes, so primary bootloader information, so we'll have in 446 bytes, first 446 bytes. Then partition table information, you know partition table, right? So if you execute the fdisk fnl, it will show the partition table. Thus all the partition table information set will be available into the next 64 bytes. Check numbers. MBR validation check in last 2 bytes. You can say magic number also. Magic number will have in 2 bytes. Okay. MBR validation check in last 2 bytes. Clear guys? It contains information about grub. The MBR contain the information about grub. ताकि next जो है MBR grub को execute करना चाहिए. ये जो MBR hold करके रखेगा, right? So about grub, RLILO. See, in RHEL 6.0 by default will have the bootloader called grub. In older version will have LILO, right? So before 5.0 we'll have the bootloader called LILO. Long back we discussed about those all stuff while we are discussing about file system hierarchy at the time, right? grub2 is a bootloader in RHEL 7.0 as well as in 8.0, and grub is a bootloader in RHEL 6.0 and then li loader in older version like 5.0, 4.0, 3.0, 2.0 version having. Okay, so it is going to execute it is having the information about grub or LILO, right? So in simple terms you can say MBR loads and executes grub bootloader. BIOS, it will execute the MBR. MBR, it is going to execute the grub, right? So grub stands for ground unified bootloader, GRAND, ground unified. So if we having the multiple kernels, grub, what it will do? Simple, guys. You are installing the dual boot operating system into your laptop, right? You are installing the dual boot operating system into your laptop, right? So you'll have the multiple operating systems, right? If you switch on the machine, the action is a post. The first action is a post. We are switch oning the machine. So each and every components it is going to, so power on self test, it is going to test. Then it orders device, then it will start. If it is starting MBR, it will execute the grub, right? So grub, what it will do in the sense, if we having the multiple kernel images means multiple operating systems, right? So it will show you grub. Okay, so if we have the multiple kernel image, for example, I have the Windows operating system as well as Linux operating system both. So it will show you both the kernel image, which one you need to choose. That's it, now. According to my requirement, we need to select the kernel image. Who is going to provide this grub? I hope you got it, guys, right? So if we have the multiple kernel images installed on your, which one to be executed, then grub displays a flash screen. You are getting one black screen, right? While you are switch on the machine, while it is booting at the time, you'll get one black screen. RHEL 7.0 kernel image Linux like this, you'll have the black screen and you'll have the two options, right? We are choosing first option, right? That is called flash screen. Got it, guys? The black screen is a which screen? Splash, SPLASS, flash screen. Okay, so waits few minutes. It will wait few minutes, right? So hardly 5 seconds it is going to wait. If you delete, if you didn't select any kernel image, automatically by default it will select the kernel image. So why it is going to select the by default kernel image? In your grub configuration file, you'll have the kernel image. According to that, it is going to select and it will start the operating system. I hope you got it, guys, right? So the grub displays the flash screen, wait few seconds, 1, 2, 3, 4, 5 like this will get, and after that it will start automatically. Okay, so enter any kernel image according to your requirement. By default it will take default kernel image, then it will start the operating system from grub configuration file, right? So grub has the knowledge of the file system. What is the difference between LILO and grub? In the sense, grub it having the knowledge of the file system, but LILO is unable to understand the file system. Got it, guys? So Linux loader so didn't understand the file system, so it doesn't have configuration file. So this is a main grub configuration file, guys. So boot, inside the boot will have the grub, inside the grub will have the grub.conf. Okay, so apart from this we have the one more configuration file, etc grub.conf. Inside the etc also will have the one grub configuration file. So etc grub.conf is a one symbolic link file for main configuration file. Got it, guys? etc grub.conf is a file. It's a one symbolic link to grub.conf, right? If you open this is a CentOS grub file, guys. CentOS 6.0, okay, operating system grub file. If you open, it will be looking like this. See here. So this is a CentOS 6.0 kernel image. 2.6.18 is a kernel image. So then the grub, what it will do, it will start this kernel image, it will start the init RD image both. I hope you got it, guys. The kernel, what it will do, sorry, the grub, what it will do, the grub, it will execute the kernel as well as init rd image. Both the images it is going to execute it by grub. Clear? Next. So as you notice from the above information, it contains the kernel and init rd image. So in simple terms, grub just loads and executes the kernel and init rd images. Got it? Next, what is a kernel? You know very well. It's a core operating system. It's a one piece of software. So we'll have the kernel image inside the grub file. Okay? Inside the grub bootloader we'll have now. Inside the grub bootloader we'll have the kernel images. Kernel mounts the root file system as specified in the root. The kernel, what it will do? It will root the mount. It will mount the root file system. Right. So now kernel execute the sbin init program. The kernel, what it will do? It will execute the first process ID called initd, right? So this is a first process ID. Okay. Since init was the first program to be executed by the Linux kernel, it has the process ID PID called 1. That's it now. So we are discussing about the monitoring and managing the operating system process at the time. The first process ID in RHEL 6.0 as well as in older version having the initd. So the kernel, what it will do? It will execute the first process ID, right? So init RD stands for initial RAM disk, guys. Init RD का जो full form होता है initial RAM disk. So what is the use of this initial RAM disk? So init RD is used by the kernel as the temporary, जैसा अभी आप system start कर रहे हो, while you are trying to starting the system, so the root mount point, it's not like ready, right? If it doesn't have the root mount point, how you can able to start the operating system? So until if it is start, temporary init RAM, init RD image it is going to use by kernel. Got it? So init RD is used by the kernel as a temporary root file system until the kernel is booted and the real root file system is mounted. जो रूट फाइल सिस्टम जो init RD जो है ना, इसको कर्नल रूट फाइल सिस्टम के जैसा टेम्पररी कंसिडर करेगा. I hope you got it, right? So clear, guys. Until the root file system, the real root file system, real root mount point, if it is until if it is mounted, then it is going to use the init RD, right? It also contains the necessary drivers complete inside which help in it to access the hard. So हम लोग hard drive के partition access करना चाहिए ना, तभी हम लोगों को operating system आ सकता है, right? So and then other hardwares. Clear, guys? Then so now the kernel, what it will do? It will execute the init programs, right? Initd. So coming to init, so it's looking at the etc init tab, guys. So ये जो thread होता है, so boot sequence के अंदर वो etc init tab के अंदर चले जाएगा. So inside the etc init tab, you will get the environment. That means graphical user interface and command line interface like this. So if we have init 0 is a halt, that means you can shut down. And init 1 single user mode, we can able to log in with the help of only one user account. Init 2 is a multi-user without NFS. Init 3 full multi-user mode. That means we can able to log in. That means CLI mode, guys. Multi-user mode, CLI mode. Okay. 4 unused, then 5 X Windows graphical mode, then 6 reboot. Guys, keep 5. Then you will get the graphical mode by default. So inside the init tab, if you having the 3, then you will get the CLI mode by default if you switch on the machine. Got it, guys? Then finally, the run level program, it will execute. For example, if you keep the graphical mode, so init run level 5, then the file it will be executed. Finally, you will get the GUI mode operating system. Login prompt will get. We need to log it. I hope you're clear, guys. Simply people, they are going to switch on the mission. This much of process, it will happen to get the login prompt. Clear? So this is a very, very important. Who's starting the career as a Linux administrator for them? 100% you will get the question from the boot process, operating system boot process. Clear? Time. Those documents also I will upload into the link. Networking documents. Actually, first yesterday onwards, I'm not feeling well, guys. Okay, so my gaya tha, so gaya jaake, right? So give me a couple of the days time. So I'm going to like upload all the documents and end of the day. No need to bother. See, if I'm giving the promise to you peoples, definitely I'm going to upload. No need to bother about that. Okay, right? Yes, no. Clear? Iris, what about online? Good. Okay, so good count, guys. So we have the only 2 days time. So still I am getting the like 40 to 50 peoples, in the sense it's good. Right. So I think like you are all having the good interest. Definitely you can do the good practical sessions, guys. If you are not doing the practical session, it's a bit difficult to you peoples to learn the Linux. Okay. So class khatam ho gaya, baat khatam hogi bolke mat chodo. Right. So class is zaruri hai. Right. So until you get the job, you need to do the practice. Okay. Good. So let's see, guys, here. We'll see now RHEL 7.0 boot process, right? RHEL 7.0 boot process, guys. So we'll have this PID, it will change now. Process ID, it will change. So same action, guys. So if you go to any operating system, if you go to the animation, the same action we should do. So first action is a post power on self test, right? So next action is a BSL. Sorry, BSL means here. See here. The first action is a post power on self test, right? So it is going to enter into the BIOS. The BIOS executes the MBR. Executes grub2, guys, here. So grub2. Okay. Grub is a legacy bootloader. Grub2, that is a legacy bootloader. Grub is. So grub2 we are using from RHEL's 8.0 onwards. Okay, it's the latest bootloader. Sorry, guys. I think grub2 we are using from RHEL 7.0 onwards. 7.0 onwards will have the grub2, right? So okay, it's 7.0 boot process only, no? So first action is, so BIOS executes the MBR. So MBR executes the grub2. So grub2 contain kernel images, initramfs images. That's it, no? So grub2 contain kernel image. So VM Linux kernel image. VM Linux means virtual machine kernel image. That's it, no? So VM Linux kernel images, and then initramfs images, right? So both will have inside the grub2, right? Next, the grub2 what executes the kernel. So it will execute the initramfs images also. So initramfs images, why we need? So kernel, it will execute the initRD image. Okay. So temporary mount point, right? So kernel, what it will do? Load the necessary drivers, modules from the initRD image. In 6.0 also will have the initRD, right? So what is the use of initram disk? It's a temporary mount point until the root it got mounted. So kernel, it is going to use the mount point, temporary mount point as a initRD, right? initRD is going to use temporary. Okay. So loads necessary driver and modules from the initRD image, starts system first process. The kernel, what it will do? It is going to start the system first process called systemd. So in RHEL 7.0 onwards, run levels will have the process ID. It got changed from 7.0 onwards. That is called system D. So the kernel, it will execute the system D. System D, it having the default target. Here we doesn't have the init run level programs, guys. Here we'll have the targets now. The run level programs here we are going to call target. So what type of targets will have? Multi-user target, graphical target, emergency target, and rescue target. Different types of targets will have. Target means if we having the multi-user target as a default target into the system D, the system D, it is going to start the CLI mode. We'll get the CLI prompt. So if you having the default target as a graphical target, you'll get the graphical mode. Rescue target, that means safe mode in Windows, right? For troubleshooting. So rescue target and emergency target. In rescue target, we can able to log in as a root user. You'll have the read and write permission for mount point, but in emergency target, read only permissions will have. So we can able to log in as a only root user. Got it, guys? How to change the targets, I will show you. Don't worry. BIOS firmware. You know about BIOS very well. So we need to enter into the BIOS. The BIOS executes the MBR, master boot record. Here also 512 bytes will have the master boot record size. So coming to master boot record, it having the three components. So primary bootloader information in 446 bytes and partition table information in 64 byte and magic number. So 2 bytes. So it will execute the grub2, guys. Okay. The different bootloader programs used on the RHEL7 is grub2. So grub2 stands for loader version 2, right? grub2 replace the old grub bootloader, also called as a legacy grub. I said na, grub is a legacy grub. Legacy means in physical machine. Legacy involvement is physical involvement only, right? So legacy grub. So the grub2 configuration file is located inside the boot grub2 grub.conf, but we should not edit this configuration file directly, guys. Don't disturb this file directly. So okay, how we need to edit this file? Got it? etc default and then magic number means that is what. So before we discuss now, what is the magic number, guys? Magic number means what is that? I said now before, what in grub MBR, right? Validation check number. Validation check number, that is called magic number. So MBR validation, it is going to validate, right? So validation check. Okay. Vikash. So clear, guys. Now etc grub, the default grub. So inside the grub, we'll have the grub.conf. So this is a configuration file. If you open, it will be looking like this. It will open grub timeout 5 seconds. Grub timeout 5 seconds. If you want to increase the time. Okay. And so it is going to execute the kernel image. If we did any modification into this grub file, the modification we need to apply this command. Without executing this command, the modification it is not going to apply. So grub2-mk-config-o/boot/grub2 grub.conf. If you're executing this, if you did the changes into the grub file, the changes it will reflect. It will update. Okay. So clearly it is saying C. Clear? Next, the grub2 execute the init RAM fs. So job initial RAM file system. Okay. So is to preload the block device method, like hard disk it is going to load, right? So it may be IDE, SCSI, RAID, whatever it may be, like if you're using, according to that it is going to start, and then finally it is going to execute the kernel, and kernel it will execute the system D. The system D according to your default default target operating system and environment. It will load the host name. So initializing network, everything it is going to up. Then SC Linux. So, okay. So print the banners and everything, hardware components, everything it will update. And then finally we'll get the operating system. Okay. So mount points and everything. So clear, guys? Virtual file system. So those all stuff. Okay. So let's see, I will show you practically how we need to change the targets and same. RHEL and CentOS both are same. RHEL for production environment and CentOS for test environment. That's it. Apart from that, it doesn't have any differences. Right? So let's see, guys. I'm going to switch on this virtual machine. If power on this virtual machine, you'll get this flash screen, guys. This is a flash screen. Right? So here, Red Hat Enterprises Linux server with the Linux 3.10. So if you didn't select any kernel image, automatically it will take. शायद 5 सेकंड कुछ आ रहा है, so automatically it will take. Okay, then we'll get the, so it is going to load the necessary bootloader programs, and then so finally it is going to execute the grub, and grub executes the kernel, and kernel it is going to execute the systemd. The systemd it is going to execute the default target. By default will have the graphical mode, graphical target. Because of that reason we'll get the graphical interface here. Okay, so now let's see here how we need to change the targets. So systemctl by default will have graphical target, right? So because of that reason, you're getting the graphical mode, right? So how to change the target? Let's see. Systemctl set hyphen default multi-user target, multi-user dot target, right? Systemctl space set hyphen default space multi-user target, then hit enter. Guys, the target it got changed in systemd now. The systemd now, if it is starting, like it is going to start the default target to target. Now we won't get the graphical mode if you reboot the operating system. Got it? See here. The target it got changed, right? So before we'll have the graphical target. Now it became multi-user target. Now it became multi-user target. Now I'm rebooting the operating system, guys. Then hit enter. So now you're going to get the CLI mode by default. See. Clear? See, we got a CLI mode. So now I'm trying to log in as a root user, right? So now let's check systemctl get hyphen default. Multi-user target will have. Rebooting, and then you'll get the graphical mode now. Got it, guys? Done. So guys, you need to switch from graphical mode to CLI mode temporary, not permanently. Okay. So we need not to change the target, but I need to change the mode, but temporary only. Okay. systemctl isolate multi-user target. Systemctl isolate space multi-user target. Then it enter GUI to CLI. Isolate graphical target. We're back to CLI to GUI. I hope you got it, guys. Like how you are using Control Alt F2 and F1. Like the same way you can use isolate command also to switch from the CLI to GUI and GUI to CLI. So right guys, I hope you clear how we need to change the targets. Okay. So how to enter into the emergency mode? Like safe mode. Windows will have the safe mode for troubleshooting, right? So like the same way, how we need to enter into the emergency mode, we'll see now. Guys, please make a note. So reboot the operating system. So reboot is a command to reboot the operating system, right? So it's rebooting. Guys, while you are getting the splash screen, at the time you need to use small E key. Small E key. So guys, please make a note. So while you are getting the splash screen, at the time you need to use small E for elephant, E key. Then you will get like this screen. So you need to find Linux 16 line. You'll have the Linux 16 line, see here. Okay, Linux 16 line. This Linux 16 line we need to find, and we should go to the end of the line using the end key. The end key, right? So use the end key, the cursor it is going to jump from the starting of the line to end of the line, right? So here we need to type, give one space, then type system d.unit. System d.unit is equal to rescue.target. Clear, guys? System d.unit is equal to rescue.target. That's it. Simple, guys. So while you are booting the operating system, right? Okay. Then Control X. Then you will get the rescue mode now. Reboot the operating system. While you are getting the kernel image, then press E, then you are into grep. Now, so there you need to find out the Linux 16 line. Go to the end of the Linux 16 line, give one space, type systemd.unit is equal to rescue.target or emergency.target. You need to enter into the emergency mode and get, you should enter into the rescue mode and go give the rescue.target and Control X. So we are in rescue.target, guys. Now we are in rescue mode. Welcome to rescue mode. See, here we can able to log in as a only root user. That's it. Only root user. So here, if we need to uninstall few softwares, so in normal mode, if you're unable to uninstall, then we can able to uninstall. Like maybe if you're having some issue with your etcfs file, if you're getting the emergency mode, go to the etcfs file, remove those entries, or otherwise comment that entries. Then you can reboot the operating system. You'll get the normal mode. Now I need to go back to the normal mode from rescue mode. Control D or systemctl load default also you can give. Okay, so control D is the best option. Control D you can use, then you have to switch from the normal mode, right? Okay, so now we'll see how to break the root password. How to break the root password. Guys, please make a note. For example, if you forgot the root password, you doesn't know the root password, how we need to break the root password, we'll see now. Ready, guys? Reboot the operating system, right? Then press E while you are getting the splash screen. Splash screen. Same thing you should do. Find out the Linux 16 line, right? To find out Linux 16 line, right? Yes, guys. Go to the end of the line. End of the line. How we need to go to the end of the line, you know very well, using end key, right? Give one space, then rd.break, rd.break. So what we need to do? Space console is equal to tty1. So guys, console is equal to tty1. It's not a mandatory because we are using virtual machine, right? So we are trying to breaking with the help of console is equal to tty1. Console we are using called tty1. If you're having the physical machine, there's the need. Break is enough. Then control X. Finish, guys. rd.break and console is equal to space console is equal to tty1 and then control X. Control X. Right. So you will get emergency mode. See, entering emergency mode, right? You'll get like this prompt called switch underscore root colon slash. So here what we need to do in the sense, we need to check the root mount point status. How to check the mount point, guys? Which command we need to use to know the mount points? Mount is a command, right? Then grep is a command to find out the root mount point. So sysroot is a mount point, guys. See, rhl-root, root mount point is a sysroot. This root, it is mounted on sysroot now, right? The sysroot, it having the only read-only permission. See, got it? It having read-only permission, right? So we need to change the permission from read-only to read and write. Clear? The mount point permission we need to change. We'll have the read-only. We need to change read-only to read and write. So how we need to mount -o means overwriting. We are trying to changing the permission. Remount comma rw sysroot. Can it enter? Mount space -o space remount comma rw space slash sysroot. Now let's verify the mount point, guys. See, the RO, it got became RW now, right? So it got became RW now. That means read and write permission we provided for this mount point for root. Right? Clear, guys? Then chroot sysroot. Now chroot command you can use. ch root, we are going to switch into the sysroot directory. Okay. That means why we are going to switch from the sysroot directory in the sense, in this situation, in this environment, you are unable to execute the shell commands. Got it? So bash shell command, password command, you are unable to execute because of that reason. 4.2, that means we are in shell now. Got it? We are in shell environment now. So shell version is 4.2 only, na bash shell version. So now password command you can execute. Then provide the root. Password root, right? Then change RHEL I'm providing, okay? Only 4 letters. The password it got updated successfully for root user. Then what we did the changes you should apply, right? We need to relabel everything. So because of that reason, inside you need to create one file called auto relabel. Auto relabel. It's a hidden file, guys. Right. So touch / dot auto relabel. So if you reboot the operating system, automatically you are going to relabel all the changes, SC Linux policies, all the file system hierarchy, what we say, directories, everything it will relabel, entire operating system. Okay, with the help of this command. Next login onwards, you doesn't have auto relabel, automatically it will delete. Then exit, then exit. We need to wait few minutes. It will take some time to relabel all the operating system. Okay, operating system necessary stuff, everything it is going to relabel. Then from next login onwards, the root user password it will change. So we need to use RHEL to log in as a root user. Okay, RHEL. Got it, guys? How to break the root password. So this is all about operating system boot process and how to break the root password, guys. So we need to wait few minutes. If you're having any doubts, any questions, please let me know. Right. So last chapter. So basic bash scripting. I'll start tomorrow and day after tomorrow. So only 2 days. That means anyone can break any mission. See, if you having the permission, then only you can able to break the password. Manjunath, right? So usually they are going to keep the grub password. So if keep the grub password, how you are going to break the root password? You are unable to enter into the grub, right? In real-time environment, we'll have the grub password. Okay. So let's see, guys. Go to not listed. Go to not listed. Then root. Then RHEL. Only 4 letters. Then we are in root user. The password, root password got, so successfully it got changed. So clear, guys, how to break the root password, how to recover the root password, whatever if you want to cancel. So this is all about the operating system boot process, right? It's very, very important chapter, guys. Okay. And we are not erasing the data, just we are trying to breaking the root user password. We'll have the same data. We doesn't have any changes in our data. But what you did the changes into the inside the switch root, The changes we should apply. Because of that reason, we are creating one hidden file called auto relabel. With the help of that auto relabel, what you read the changes, everything it will be relabeling. That's it. You are not going to lose any data. Right? Kuch doubt? So thank you guys. Actually, the thing is, really, I'm founding like good strength still. In offline, I think we'll have the more than 12 people, I think, right? Start 10 people, I think 9 people will have good. Online, 46, 47 people, I think I find. So thank you. So please do the practical session. So we'll have the only 2 sessions, tomorrow and day after tomorrow. Otherwise, if you need, I'll complete tomorrow itself only. I'll take little bit more, like more than 7:30, and then I'll finish it. Your wish. So 2 दिन चाहिए तो 2 दिन पढ़ाऊंगा, 1 दिन में पढ़ाऊंगा बोले तो नहीं यार, कुछ भी नहीं. Make it 2 days. Okay. No. So few people, if we are feeling bored, like so because of that reason I'm saying. So from my side, I doesn't have any issue. मैं 4 दिन में पढ़ा सकता हूँ, कुछ प्रॉब्लम नहीं है, right? Right. I think बहुत ज़्यादा time तो ले लिया, right? We have AWS, sir. We can't. Okay, no issues, right? Yes, guys. You're feeling this class. You're feeling this is a basic Linux. Huh? So I hope like you're learning something from me, right? So that means about Linux. Yes. So maybe who doesn't know about Linux, so they have some idea now. Yes, no. So I said the starting day itself only. So please stay with us continuously for 30 to 35 days after completing this course. So are you feeling like that, or otherwise you have any doubts, tell me. So okay. Getting clear. Good. Thank you.